Welcome to Information Service Engineering. This is lecture number 4, Linked Data Engineering Part 2. Now in this part of the lecture you will learn how to query RDF data with the help of the SPARQL query language. SPARQL is the query language for the semantic web and for linked data technologies. As such, it is a component of the semantic web technology stack. In there you have RDF data, and there are so-called databases which comprise RDF triples, so called triple stores, and triple stores can be queried with the help of exactly this SPARQL query language, which is some derivative, or it's similar to existing query languages for relational databases like SQL, for example. So some of you who had a database course might know SQL. SPARQL is not so different in the syntax from SQL, but you will see how it works. So now let's use SPARQL and query on. SPARQL is more than just a plain query language. It also defines the protocol by which a client asks a SPARQL server. So as a client, usually we are dealing with SPARQL over the web. So we have the browser, and in our browser there is a user interface where it's the client, and exactly this client sends a SPARQL query to a SPARQL server. Of course, via the web protocol HTTP, it goes to the web server and then will be relayed to the SPARQL endpoint, which resides in some database server on the server side. So HTTP is the basis of the communication protocol, and on top of it there is another layer, and there's the SPARQL protocol layer in which the entire SPARQL query with all required parameters will be specified. But you should not take care of this. This is only for an explanation how this works. In principle, for you it will be important to know how SPARQL works as a query language. So to access SPARQL endpoints on the web, there are specific SPARQL endpoints. And these endpoints usually look like, for example, this one. This is a so-called Virtuoso server, and it provides a user interface like that where you can put in your SPARQL query, send it away, and receive the results. This is already a relatively prominent or popular SPARQL endpoint. It's the endpoint of the online knowledge-based DBpedia, which is the semantic version of the popular Wikipedia encyclopedia. We will talk about DBpedia later on also in the course of this lecture, and it will serve for us as a perfect endpoint, providing lots of data, of course in the form of RDF, and we can use the SPARQL query language to make sophisticated queries on top of that huge knowledge base. Whenever we do these SPARQL queries, you will see usually in the upper right corner a link like this one here, which brings you then directly to the SPARQL endpoint, including the query that we are trying to question here. Okay, I will show you that later on. SPARQL, again as a reminder, defines first of all the query language that we will take care of now, and usually this query language, we will see this later on, is working in the terms of a graph traversal. You know that RDF data can be represented, these triples form a huge graph, and what the query language does, it follows the graph and filters out, of course, things which we try to query for. So it's a graph filtering, graph traversal query language. Then, as I already told you, there is a protocol layer, and this protocol layer defines how we can make use of SPARQL via the HTTP protocol. And of course, the SPARQL server then in the end also returns an answer, and SPARQL also defines the way how this output format is specified, is represented, and is encoded. So this then is the XML output format specification for the SPARQL query language. And all of that is put together in a W3C web standard. And now we have SPARQL 1.1, and this standard has been published in March 2013. And like I already told you, the SPARQL query language is inspired by the SQL query language for relational databases. Okay, let's start with SPARQL queries. We want to query RDF data. So usually if we want to query something, we need variables. Variables in the end, via the graph traversal, will be bound to specific RDF terms, RDF values, subject, objects, whatever. But we have to distinguish in our SPARQL queries variables from entities or values which are RDF. And usually you do this by using a name string for the entity you are querying for, and in front of the name string you are putting a question mark, and everything which starts with a question mark then in a SPARQL query will be a variable. Now, when we want to query something, and now this is pretty similar to the SQL query language, we use the select command. You know select from SQL, also there is a select in SPARQL. And then you state what kind of variables you want to select in a statement. So you select here, for example, 3 variables that you have named title, author, and published. Yeah, we don't have to worry how this exactly is carried out, only to see that this is, let's say, a most simple and basic part of a SPARQL query. Now, what comes back then will be something like a table which consists exactly from these variables you have queried. And these variables usually in the term of the graph traversal are bound to specific RDF values. So here we have the query, and then the table that is returned could probably look like that. This will be a SPARQL result. You will have 3 columns here. Each column is headed by exactly the name of the variable you are querying for, and then you have a column for title, you have a column for author, and you have a column for published, and everything is organized as a table. So this is a typical SPARQL result. Okay, but of course this is not all. Let's see how SPARQL really works. I told you that this is a graph pattern matching on a RDF graph. So SPARQL, first of all, when I do a query, is based on the RDF turtle serialization. So everything you express in SPARQL is inspired by turtle. And second on, you do a so-called basic graph pattern matching. What is that? In a basic graph pattern, you have a triple pattern, which means subject, predicate, object, in which any of these triple components, either subject, property, or object, can be replaced by an arbitrary variable. So, a graph triple pattern is nothing else but turtle plus the use of variables. And this is a rather easy example. So for example, if I am looking for books and their authors, and I'm using for that a specific vocabulary that has been defined in the DBpedia ontology, so this is this RDF expression DBO author. This comes from DBpedia. We will later see how this vocabulary really works and how this ontology works. There I'm looking for books, not one book, all books that exist, which are connected exactly via this property, DBO author, to some author. No further restriction. So this is quite easy. And this then is, or we define a basic graph pattern, BGP, as being a set of exactly those triple patterns. And what you have in a SPARQL query then is not only, of course, one triple pattern, it's a set of triple patterns, and this is then a SPARQL query consists of basic graph patterns. That's it. No more, no less. Now let's see how this query usually is executed. But this, of course, is a simplification of that. But in principle, it works like that. So this is your triple pattern. You are looking for books which are connected via the property DBO author to some author. And here you have, as an example, an RDF graph. So now, pattern by pattern, or triple by triple, this pattern goes through the entire graph. And by doing that, usually the matching lines, which means lines which here in that case for our triple pattern match exactly DBO author, they are returned in the result. So it's this one where we have Oliver Twist has been authored by Charles Dickens, and the other one, I, Robot, has been authored by Isaac Asimov. So you see, it's a graph traversal, so all the triples are checked and then filtered for these triple patterns. This is how SPARQL in principle works. But of course, there are several optimization methods to make these queries more efficient and to make the execution of the queries more efficient. They are working in the background, but usually it works like that. Okay, so when I now combine specific graph patterns together, they form so-called complex or conjunctive queries. So usually if I have one graph pattern and another graph pattern and I state them following one the other in a SPARQL query, what you get is usually then a conjunctive query which combines both result sets that are created by both of these graph patterns in a conjunctive way. So here, for example, I try to find books, their authors, as well as the release date of these books, which means I look for a pattern, first book, then DBO author, and then I simply add a second pattern which says, okay, exactly this book should have a specific release date, therefore I use DBO release date as a property, and then another variable which I call date. Note that here also these graph patterns, they have been closed with a period. So this is turtle. Remember, it's turtle, you have to close your statement with a period. Okay, let's look at a more complicated or more complex pattern. So here, for example, given you have a URI which has been defined in the FOF vocabulary, which is a rather prominent vocabulary for expressing people's addresses and friendship relations. So FOF is a rather interesting vocabulary, popular vocabulary that is used there. So given we have a specific FOF URI, for example, my FOF URI here, let's find the name of a person and her friends. How does it work? Okay, we have this FOF URI. Here we have HTTP, HPI, web.de, and then there is an ID, which is my ID. And then we use the FOF vocabulary to find out what is the name. So we say property FOF name should be there. And then we have a variable surname. And then you see, again, this is turtle. We would now immediately add a second graph pattern, which starts with exactly the same subject. Therefore, we are using the shortcut, we are using a semicolon, which means the same subject is used in the subsequent pattern. And then we are using FOF knows, another property, which in the end states that, okay, I'm looking for all the people that I know and they should be gathered here in the object, and this is the new variable friend. And then I do a period. And since I do not only want to have the URI of the friend, but also the name of the friend, I add an additional graph pattern where I say friend should have the FOF name, and then comes a variable for the surname of the friend. So FOF name then will be again from the FOF vocabulary. You see, this is a way how I can easily conjunctively combine different graph patterns to form rather complex queries. Now you might say, oh, this looks really, really complicated, but you will see in course of the next 2 or 3 small lectures that we have here considering SPARQL. SPARQL is not so complicated, and it's a rather powerful means to cope exactly with these kind of queries. But it's rather easy, you will see. Okay, now we reached a point where I can show you the entire general SPARQL query format. We know already SPARQL is based on turtle, so therefore, to make life easier, I will use prefixes. So I define prefixes to make all my SPARQL query much easier readable. So this is my first intention. So what I do here, for example, I define the namespaces that I require. First of all, I say my most basic namespace here, simply denoted by a colon. This is the DBpedia namespace, and then I define a namespace for RDF, I define a namespace for RDFS, and also I define a namespace for the DBpedia ontology to make life easier. So this is my namespaces. What do I want to do with that query? It states we want to search for all the authors and all the titles of their notable works. Okay. So let's start. First of all, we need a select statement. So we select certain variables. So in our resulting table, there should be the author name and probably then the titles of their notable works. So we have 2 columns. One will be author name, one will be the title. And these are the variables which are usually noted directly subsequently to the select keyword. Next keyword we see here, it's the from clause, which is part of the select statement. From usually defines from which graph, from which RDF graph I want to query. It should be a graph that is available on the SPARQL endpoint you are dealing with, and there can be several graphs. And these graphs usually are identified via their namespace. So here it's http dbpedia.org. So we are querying here the dbpedia namespace and the dbpedia graph. And of course, this query that it works has to be put to a SPARQL endpoint where exactly this graph is available. So, okay, this is the from clause, and it specifies the graph to be queried. Now comes the most interesting clause. This is the where clause, where we specify different graph patterns that have to be combined. And usually these patterns, or the combination of these patterns, there is the intelligence in the query, and it shows you how to combine which components of the graph to achieve exactly the answer that you want to. Let's have a look at that. Here we are looking for writers, which means we are looking for a variable author, which should be of type writer. And then, of course, we do not want to have simply the URI, which would be returned here. We want to have the name. So we select the RDFS label of exactly this author and assign it to the variable author name. And then, of course, we are looking for the notable works of exactly these authors. So we have the next triple, author, DBO, notable work, and work. Work is now the third variable we need here. And of course, we do not want to have the URI of the work. What we want to have is then in the end the title, and the title, of course, in a human readable form, usually will be then behind the RDFS label of this work. And this title then is our fourth variable. And in the result that will be displayed after that, we will have the author name as well as the title. So this is the general SPARQL query format. Besides that, okay, we can add, of course, several filtering, output filtering especially. So what you do here, for example, you can say, yeah, I receive lots of results. First of all, to make sense of it, order them. So you can order them, for example, alphabetically, you can order them numerically. It depends on which variable you want to order your output. So you can specify here exactly in that solution sequence modifier space, you can say, okay, I want to order my results according to the author name. And this ordering should be ascending. So it should be start with A and should end with Z. So this is alphabetically, since you have strings in there. And of course, it should be in an ascending order. You could also write order by descending, then it would be the reverse order. Another thing what you could do here to modify your output is you could say, okay, I get millions of results. I don't want to have millions of results. This would spoil or waste my entire bandwidth. Give me only the first 100 to see whether my query works or not. For that, I use an output modifier, which is the keyword limit. And with the keyword limit, I limit my output to 100 lines here. So you specify after limit exactly the number of results you want to have. And in case you do not want to start with the first one, you can say, okay, I can define an offset, when to start. So for this, you are using the keyword offset, and after offset, you specify the position where to start. Here in that case, we start at position 10. So look at the query that we are asking here. It says search all authors and the titles of their notable works, ordered by authors in ascending order, and limit the results to the first 100 results, starting the list at offset 10 position. And here in the upper right corner, you see that blue link which says Query SPARQL Endpoint. And if we go there and click on it, just try this also at home, it will directly connect you to the SPARQL endpoint of the dbpedia while transferring exactly this query into the query box here. So you see the query box also here with the prefix definition, the select statement, exactly the same like we had on the slide. Now, to execute the query, you click the button here on the lower left corner, which says Run Query. I click on it, and you see the result is a table consisting of two columns. We have author name, we have title, and of course they are mixed completely wild. So here you have, for example, the English author name of a guy who is named Aaron Covington. I don't know that guy, and he has written a book which is called Creed. And of course, this book has the same title here, for example, in Dutch. It has a slightly different title in Polish. It has a strange title in Japanese, and so on and so on. So you see lots of information. And of course, we have limited this information to the first 100 lines and started somehow, we have to believe this, at position 10. So this would be our very first query here. Okay. So let's proceed. The next interesting refinement of our query would be not only to use single query patterns, but to ask for certain restrictions, which means we want to further filter the results by putting restrictions on some of the variables. And you do this usually via the keyword filter. You see here, this is a filter restriction that specifies constraints to the result. So this is exactly the same query we had. We are looking for writers and their names, and we are looking for their notable work. And now there's something new. We want only take into account notable works, so this means books, which have more than 500 pages. So therefore we are specifying a graph pattern which says work, and then connects the work with the number of pages of that work, so DBO number of pages, again from the vocabulary of the DBpedia ontology. And if there is a pages, or if there is the number of pages given for exactly the book we are looking for, we are putting a filter restriction there which says, okay, only return those where this variable pages is larger or greater than 500. This is our query, and with that I can exactly filter or put sophisticated constraints. I can specify constraints for the result. Let's try this out on the SPARQL endpoint. Here is exactly the same query again, and I will run the query. And you see here we have a number of books, and of course I did not make any restrictions in what language of course I want to have the result. Therefore I find here Victor Hugo's Hunchback of Notre Dame rather often, but I see here it has more than 500 pages. So here, for example, a page number of 940 pages is given. Interesting thing, you also see lots of, lots of translations of the title of the book of the Hunchback of Notre Dame. That's quite nice. Okay, so let's continue. The filter keyword, by that we putting constraints or filter restrictions to specific variables. What I can do here is I can also apply operators that I can apply on variables, or also I can apply within my filter restrictions. And there are several so-called unary operators I can use. For example, if I have a Boolean value, I can switch or complement this Boolean value by a negation. This is here this exclamation mark that I put in front of the variable or the expression that I want to have complemented. Or if I'm dealing with numerical values, I can specify whether they should be positive or negative by using the unary operator plus or minus, which signifies this result should be interpreted positive or this result should be interpreted negative. But this only works for numeric values. Then I have specific other unary operators, for example, bound. This asks, when applied to a variable, whether the variable has a value or not. So whether some RDF expression or from our RDF database in the result is really assigned to that variable. If not, then bound will be false. So the result will be a Boolean value. If bound yes, then the result is true. If bound no, then the result will be negative or false. Then we can ask whether a specific RDF term represents a URI or not. Again, the result can be Boolean, true or false. We can ask whether the RDF term is a blank node, and we can also ask whether the RDF term is a literal or not. The next three are also interesting. str modifies exactly the result. It simply converts any literal or URL into a simple string. So str of for example, a URI, will convert that URI into a string, and we can further process it if we want to do that. Then you have the language unary operator, and this gives you back, if you apply it to a variable which is a string, this gives back the language of the string. So we have seen many strings here, for example, defined being in English or in Spanish, Polish, Japanese, and so on inside DBpedia. And this could be also interesting then to filter out specific languages or to compare specific strings in specific languages. And not only the language is interesting information, also the data type. So for literals which are typed literals, I can always extract also the according data type, and the result then will be given in the URI of that data type. So these are the so-called SPARQL unary operators. And in the next slide you see how they can be applied. Let's stay with the example where we filter for a specific language, and here we only want to have labels within the English language. So you see I have added 2 additional filter constraints. One filter constraint is standing here, is placed here where the author name is extracted, and we say here the author name should be filtered, and only, of course, author names should be then in the result for which the language of the author name is English. And the same is done here in the last line where I filter the title, and I also say the title should be the English title. Which means if I now execute this SPARQL query, all the results of the author names and of the title names, which before were completely mixed together, will now only be the English versions. Let's have a look. Okay, here is our SPARQL query, and I will run it, and you see here the result. Now it's in English, so Victor Hugo's Hunchback of Notre Dame, only the English title. Let's see, are there other authors that we probably know? Probably you know Haruki Murakami, very interesting Japanese author. Or let's see, another one, Henry James, also rather famous author. So you see here lots of authors, and you remember the other restriction. All of these books must have more than 500 pages. Here is one with 2,000 pages, that's interesting. Alberto Moravia, seems to be an Italian guy. Racconti Romani. This means Roman tales. Interesting. I don't know that, so probably you can use this as an inspiration for further reading material. Okay, so this was our first excursus into SPARQL. In the next lecture, you will learn how to query more complex SPARQL queries.